In September 1859, scientists observed the first confirmed powerful solar flare. The sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problems for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar-charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies would go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the sun increases every year, then we'll have to come up with new, innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the sun are similar to this tousled hair. When the sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere. Uh-oh, a strong wind is blowing. Black clouds cover the sky. Thunder is rumbling and is pouring down with rain. A storm is coming, but you don't care. You're sitting in your apartment listening to music and typing something on your computer. You hear a thunderclap. Look out the window and see a heavy downpour, a tornado, and lightning flashes. You close all the windows and go back to the computer. And then, bam! It seems that lightning has struck near your house. Your laptop and all electrical appliances in the home go off. The light goes out. You get scared. At this moment, you hear a strange hissing sound. You see how, like a phantom, a round, glowing ball of electricity flies into your house through a closed window. It penetrates your room, hovers in the air, waits for something, and then flies back through the walls. The lights turn on, and everything comes back to normal. You've just seen a real natural phenomenon called ball lightning, and you're fortunate to be alive after meeting it. This is a rare phenomenon. Ball lightning occurs during a thunderstorm in the form of a floating sphere. It can change color from blue to orange and yellow. It's the approximate size of a basketball, but can also be much more significant. This lightning makes a hissing sound and a pungent smell. Phew! The first records of ball lightning were made in 1638 in England. Then, a giant glowing ball flew into the church window. Since then, there have been a lot of evidence of how ball lightning got into houses and frightened people. In the 20th and 21st centuries, scientists actively investigated this phenomenon. They found out that half of the cases with ball lightning were just hallucinations caused by magnetic fields during a thunderstorm. But they couldn't wholly refute the fact of the existence of ball lightning. They agreed that this phenomenon existed, and once they even managed to record it. The phenomenon of ball lightning was caught in China. Researchers studied the behavior of thunderstorms in 2012 using video cameras and spectrometers. They saw an unusual lightning strike, after which the ball appeared. It flew horizontally about 33 feet and disappeared. The spectrometer showed that the ball consisted of silicon, iron, and calcium. If it's real, then what is its nature? There are several theories. Perhaps the ball lightning occurs as a result of a lightning strike on the ground. Oxygen and evaporated elements from the soil create a reaction in the form of a round clot of energy. This explains why the spectrometer in 2012 recorded the same calcium in the ball lightning as in the ground. Another theory says that glass can generate these balls. Atmospheric ions accumulate on the glass surface and create an electric field. Together with a lightning strike, this field turns into ball lightning. That's why there's so much evidence that the sphere flies into the building through the window. In 2016, scientists pointed out that a lightning strike on the ground created microwave radiation that can form into a plasma bubble. This floating electric plasma takes a round shape and hovers in the air for a few seconds. Earthquakes can cause ball lightning too. During ground tremors, flashes of light appear from the depths of the crust. It's like lightning that comes not from the sky, but from the ground. Some of these lights may look like floating blue spheres. In 2014, scientists studied earthquake lights and found that some rocks emit electrical discharges during seismic wave impacts. In 2006, researchers at a university in Tel Aviv created a laboratory to study ball lightning. They used microwave radiation to recreate a lightning-like electric charge. In 2018, quantum physicists made a complex synthetic magnetic field similar to ball lightning. Physicists, chemists, meteorologists, and other scientists have conducted research and laboratory experiments many times to understand the nature of this phenomenon. But so far, no one has succeeded. Other glowing balls are less dangerous, but still mysterious. In clear weather, you can see strange glowing lights away from cities, somewhere in a swampy area. Previously, when there was no electricity, people noticed these lights. They thought someone needed help. What if some guy is stuck in the swamp and shines a kerosene lamp to get seen? People went to these lights to help, but fell into the swamp, and the light either flew away or disappeared. Some records speak of several lights at once. They move quickly and change their colors. Many believe that these were some kind of mystical creatures that lured people into traps. But over time, scientists managed to uncover the mystery of this phenomenon. Bioluminescent fungi and algae grow in swampy places. Sometimes they glow with blue light and create the illusion of glowing lights from a distance. Also, there's a lot of plant material in the swamps: leaves, grass, mud, clay, and tree branches. These substances decompose rapidly in humid conditions and release methane. As soon as methane contacts air, it ignites. The flame flies over the swamp in the form of a burning ball. Mysterious lights appear not only in swamps. People see them in deserts or mountainous areas. Sometimes it's headlights from cars. In other cases, it's the signal lights of an airplane. But in many cases, the nature of such lights remains unknown. And now, imagine a huge ball the size of a small city. It's like a dome, covers a large area, and protects it from tornadoes and storms. This phenomenon is called the Delco weather bubble and is located in Delaware County, Pennsylvania. That's how it all started. In 1996, one of the strongest snowstorms of the 20th century hit the U.S. East Coast. It was named the Blizzard of 1996. It covered almost all of Pennsylvania, but in the small town of Delaware County, Delco for short, the weather was good. The storm raged around but didn't touch the city. Since that year, the locals have believed that an abnormal weather bubble protects their houses. However, there's no scientific evidence of the existence of this bubble. After the blizzard of 1996, there were several more storms in the area, and forecasters claimed some storms would also cover Delco. But contrary to their forecasts, the weather there was excellent. Strangely, there is no meteorological evidence of this. One of the residents decided to investigate this phenomenon seriously. He followed the weather forecasts, looked at satellite photos, and saw how the black clouds diverged around the city. It rained heavily in the neighboring towns, but not Delco. This seems like convincing proof. And the question remains, should we believe the locals? There's one scientific explanation explaining the nature of this phenomenon. Storms may weaken here thanks to the sea air that accumulates in the Delco area. The street and the city's surrounding area are filled with this humid, cold air. It creates a sort of stabilization of the atmosphere, and when intense storms from the west collide with Delco's air, they lose a significant part of their strength. And it seems as if bad weather just bypasses the city. But there's another explanation, a psychological one. All the known information about the weather bubble came from the stories of residents. They see confirmation of this phenomenon and write about it on social media. Someone said that they'd seen a tornado pass by his house. Others claimed that the bubble had saved them from a downpour. People think that it didn't affect others if there was no trouble with their house. Imagine the TV says that a storm has started in your city. You look out of the window and see a clear sky, no wind and rain. It seems to you that the bubble has saved you again. Although behind you, a few hundred feet from your backyard, a tornado is raging and tearing the roofs off of buildings. But you didn't see it and wrote to the social network that Delco has saved your city again. In this sense, the weather bubble becomes more like a virtual one, thanks to the people who write about it.
On some nights, when the sky over a powerful thunderstorm is clear, you might see elves, gnomes, trolls, or blue jets. Blue jets sound kinda random here, right? But we're not actually talking about fairy tales. These are all just different types of lightning flashes that are mostly visible very high above raging thunderstorm clouds. Let's take red sprites. Those are flashes of light that appear above thunderstorms that come in clusters. They are rare because they're only caused by a specific type of lightning called positive cloud-to-ground strikes. So a positive charge is transferred from a thundercloud to the ground during a lightning strike. These types of lightning make up only 10% of all lightning strikes. For more than half a century, many believed these flashes were just urban legends. People did see them from time to time, but the flashes were so brief that even if you had been lucky enough to catch them, you wouldn't have had time to call someone to witness this phenomenon with you. Even when respectable scientists or pilots would talk about them, the scientific community would mostly ignore them. In 1989, something strange happened. The researchers from the University of Minnesota actually managed to catch sprites on film, and that's how it started. People across the world began sharing videos and photos of red sprites. Red sprites can start as 328-foot balls made of ionized air. These balls shoot down from heights of about 50 miles at 10% of the speed of light. And researchers have been studying not only the lightning that plunges down from raging clouds, but these colorful flashes that go towards space too. So, electricity stretches up to the electrically charged ionosphere, but at the same time, it crushes down towards the ground. Red sprites come in different shapes, like these big, cool jellyfish sprites that sometimes have areas that measure up to 30 square miles. You may see carrot sprites or column sprites. They're similar, it's just that carrots also have long tendrils. The lower parts of tendrils are often blue, while the higher ones are red. On August 22, 2022, we were able to take some stunning photos of red-white streaks in the sky above the Atacama Desert in Chile. They were surrounded by another bigger glow of greenish color. It's something we call air glow, and you can only see it this well when there's no light pollution. It's basically when we use too much artificial light, and among other things, it doesn't allow us to observe stars and other objects we might otherwise see in the sky. And this air glow happens because of atoms of nitrogen and oxygen in our atmosphere. Sunlight knocks away their electrons during daytime. Then, they slowly recombine with their electrons, which is a process that causes them to glow. How can you see a red sprite? First, you need to find a large thunderstorm. They're more common during summer and spring, for example in June. Of course, sprites can appear at any time if there are powerful enough storms with lightning at ground level. The skies need to be clear and very dark, ideally without bright moonlight. And the storm should be around 100 to 200 miles away. That way, clouds won't block the sky and you'll have better visibility. In the perfect scenario, the storm will be moving along a distant horizon, so you'll be able to see everything above the cloud tops. You can track a storm with weather radar. Your eyes need some time to adapt to the darkness around you. Give them some time, about 20 to 30 minutes. Keep your eyes above the clouds and try not to look at the clouds directly. Ignore lightning flashes. A sprite will pop maybe once for every 200 lightning strikes. Don't expect to really capture it on camera, it's not easy. But the view itself will likely be worth the wait. This and similar flashy events are something we call TLEs, which stands for Transient Luminous Events. Blue jets are also worth mentioning. These are dim blue lights that stream up like a very fast puff of smoke above powerful hailstorms. They're also very rare, and in most cases, you'll only be able to see them from an airplane. And now we get to those fairy tale creatures. Elves, when we talk about lightning flashes, are brief disks of dim light you can see about 60 miles high in the atmosphere. It's just an abbreviation. Their full name is emissions of light and very low frequency perturbations due to electromagnetic pulse sources. Yeah, I suggest we stick to elves. Moving to trolls. Those are red spots that pop close to cloud tops after the flash of a very powerful red sprite. Gnomes are the smallest and fastest flashes. We're talking about tiny white spikes of light that flash from the top of a big anvil of thunderclouds. The anvil is that elongated cloud you see at the top of a raging storm. It spreads downwind together with upper-level winds, and gnomes last for only a microsecond. And check this out. Ball lightning is in the shape of fiery orbs that can be as big as a golf ball or can grow up to a very large beach ball. They can be yellow, red, white, orange, green, or purple, and they can stay alive for a couple of seconds, even minutes sometimes. For the centuries, many people have been talking about how they saw ball lightning, sometimes even floating into their homes. But such events are really unpredictable and happen very rarely. Scientists have managed to recreate ball lightning in the lab, or at least something very similar to it. They have realized that ball lightning probably shows up after a lightning bolt strikes the ground. Mineral grains in the soil then vaporize. Here's something spectacular: volcanic lightning. This one is born in the plumes of a wild volcanic eruption. Like the rest of thunderstorms, volcanic lightning forms when static electricity builds up in Earth's atmosphere. And then it gets released in the shape of a lightning bolt. Scientists don't understand the whole mechanism here, but they think it's related to charging. For example, ice charging is what causes thunderstorms to form. It plays a part in producing lightning during volcanic eruptions too. This happens when the air heated in an eruption rises into the sky and meets cold air. The water from the eruption turns into ice particles, and when these particles bump into each other, some electrons get knocked off. The ice particles that now have more positive charges move higher into the sky and gather together. Or it may be frictional charging. another thing that leads to volcanic lightning. The same as ice charging happens when tiny particles of ice collide. Here we have ash and pieces of rock colliding and creating charged ions. There's dark lightning too. Over 10 years ago, researchers discovered that thunderstorms could generate brief but very strong bursts of gamma rays, which is the form of light with the highest energy. They are so bright that they can blind sensors on satellites, even when they're hundreds of miles away. They can also create antimatter. Antimatter is a type of matter made of particles with opposite charges compared to the particles in normal matter. Imagine having two boxes full of blocks. Some blocks are red and some are blue. When these pairs touch each other, they disappear or annihilate and turn into energy. That's what happens when particles of matter and antimatter meet. And these flashes could be the result of dark lightning because it gives off light that's not really visible. Regular lightning involves slow electrons. In dark lightning, electrons are high energy. They crash into air molecules and, by doing that, produce gamma rays.
When lightning flashes across the sky, it releases somewhere around 300 million volts, or the equivalent to power 25 million car batteries. Some say you're more likely to be zapped by lightning in your lifetime than to win the lottery. And statistics seem to prove this urban myth, as each year around 28 US locals do get electrically charged from the sky. The world's infrastructure can be affected by lightning too. That's because it generally seeks out the tallest structure around. But in certain conditions, it can also strike an open field. So scientists came together and invented a laser lightning rod that might help. This unique invention might make lightning strikes a bit more manageable, since it can guard a much larger area than the traditional one, and it's flexible. Classic lightning rods work like magnets for that powerful electrical charge. There are these tall metal devices placed on top of buildings. When a storm approaches, the rod provides an easy path for lightning to follow, preventing it from hitting other parts of the structure. The rod is also connected to the ground with a conductor, like a wire, helping the electrical charge to safely make its way into the earth. This process protects the building and the humans in it by directing the electrical energy away. We've been using lightning rods for the last 300 years, courtesy of Benjamin Franklin. But they're not damage-proof. When it comes to safeguarding vast spaces like airports, they can't manage. That's because they can only cover an area proportional to their height. Here's where this new, improved lightning rod can help. When the laser zaps the sky, it leaves behind a trail of superheated air called plasma. The same way a sculptor carves out traces in clay, the laser creates channels in the air. These channels then become the lightning's new favorite route, guiding it down to the ground. This new method was tested in the Swiss Alps back in 2021, and the results were promising. These lasers do have their own disadvantages. They aren't always available and need a heads up. That's because they have to be activated before a bolt hits. If you're a second too late, tough luck. Also, once the laser stops, the air loses its conductivity pretty quickly. This means the laser rod might not have enough power to guide the lightning safely. A potential solution might be monitoring the electric field around a certain area, predicting where lightning might strike. Yet, these new rods still need more testing and lots of funds. The European Space Agency found another way to make lasers useful: to turn moon dust into roads. It would make our future lunar exploration missions much easier if a laser beam could do the hard jobs, allowing astronauts to drive around the moon. This discovery might also help with another tricky issue: moon dust clinging to everything in sight. Roads on the moon might seem too much of a hustle for now, since we haven't been to our satellite since 1972. But when future space explorers will touch down again, they don't just plan to walk small distances. It'll be nice to have them driving around so they can explore larger areas. Problem is, that pesky moon dust is very fine, abrasive, and sticky. Back during the Apollo missions, it clogged up equipment, eroded spacesuits, and even caused a lunar rover to overheat. That's why scientists want to zap simulated moon dirt with a laser. This laser-powered project used a 12-kilowatt laser to melt simulated moon dirt into a solid, glassy surface, perfect for moon roads. The plan isn't to send a huge laser on the moon. This device they're testing here on Earth is like a stand-in for the sun, mimicking what lunar sunlight could do. The idea is to eventually concentrate sunlight using a big lens on the moon's surface. Some experiments have been done so far with different laser sizes, finding that a bigger beam made the whole process go smoother. Instead of dealing with tiny molten balls, they got a stable layer of molten moon dirt that's easier to work with. What they got was a glassy, somewhat brittle material that can handle downward forces. And even if it cracks, it's fixable. The laser beam was used to make triangle-shaped road parts that fit together like puzzle pieces, forming solid surfaces across lunar soil. If this goes as planned, we'll have moon roads made of interlocked triangles. This unique type of moon pavement could be the solution for landing pads too. Lasers can help piece together information on long-lost civilizations too. Discovering Maya cities has always been difficult for researchers exploring Mexico's Yucatan Peninsula. For years, experts believed no early civilization could have thrived in that harsh environment. But advancements like light mapping technology and laser scans are showing us this might not be true. LiDAR technology can lend a helping hand for archaeologists, especially in areas that are hard to physically reach. That's because it's like we're equipping computers with a pair of eyes. The whole thing works as a flashlight, sending out small light beams in the form of a pulsated laser. These beams bounce off objects like trees and buildings and come back to the flashlight. LiDAR measures how long it takes for the light to return, creating a map of the surroundings. When a self-driving car or robot wants to know where it is, it uses LiDAR to send out these light beams. By figuring out how long they take to come back and where they hit, the car or robot can understand what's around it, making it safer for them to move around through the fog or at nighttime without bumping into things. With this technology, a team uncovered the massive Maya city of Acomtun. LiDAR technology helped researchers to map the jungle floor, revealing hidden structures. Yet someone still needed to verify these findings on foot. The journey to Acomtun wasn't extremely challenging. The region, quite far from the nearest airport, is mostly unexplored, accessible only through old hunting and logging routes. The dense terrain made the trek challenging, taking the team up to 2 weeks to cover just 30 miles. But the effort paid off, revealing monumental structures like a large acropolis and intriguing shapes hinting at a marketplace or cultural center. LiDAR is also used in rovers we'll need to explore other planets. This will allow the robots we send up there to navigate their surroundings without direct human indications. It's also helped us better understand the best location to place solar panels, making it cheaper and faster for us to meet our energy needs. We might also be able to use lasers to predict how a volcano is gonna act. These structures are loaded with magma, the molten rock sneaking upwards from the Earth's insides. When a volcano blows its top, a chemical reaction happens, transforming magma into what we call lava. The specialists behind this new use of lasers think of magma as the computer code of volcanoes. It reveals information on how a volcano might pop up. That's because not all eruptions bring lava, and even if they do, there are different lava types, depending on how runny it is. Magma is like a mix of liquid, gas, and crystals that are shaken up inside the volcano. There are many elements at play before a volcanic eruption, so it's hard to study and understand that complex chemistry. To organize things around a bit, scientists hit the cooled magma, the rock matrix, with a laser, just like the ones you might have encountered if you've ever had eye surgery. It makes the chemical components easier to study. This latest laser eye method was used on samples from a 2021 eruption, which lasted 85 days. It covered over 4 square miles, spewing loads of lava that wrecked over 1,000 homes and displaced over 7,000 people. To prevent such events from happening again, scientists need more data. It's true, earthquakes and ground shifts help specialists predict what a volcano might do. But knowing a bit more about its chemistry can help a bit more.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under 2 continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the Moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England Highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the Sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the Sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed 2 enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.
You're dozing off in your window seat on a plane. It's getting dark since it's almost 11 p.m. Suddenly, something wakes you up. You glance out of the window and see a really strange phenomenon, something that creeps you out. There are bright red, huge flashes illuminating the sky at a distance. They resemble some nightmarish jellyfish. Those are sprites, also called red sprites due to their color. They're also known as cloud-to-space lightning. These varied visual shapes flickering in the night sky are large-scale electric discharges, which is a clever word for a lightning strike. They occur high above thunderstorm clouds at altitudes of 30 to 56 miles. That's why you can see them so well from your plane window. The coolest thing about sprites is that they're positively charged lightning. This is a very rare type that makes up a mere 5% of all lightning strikes. People first spotted this phenomenon in 1886, and it was first photographed in 1989. In 2018, the legendary Niagara Falls, located at the border between New York State and Ontario, Canada, managed to surprise everyone. Tourists who came to admire the roaring waters found the falls frozen. Well, the waterfalls weren't frozen per se. This is impossible for a mass of flowing water that huge, but microscopic water droplets, as well as the mist, formed a crust of ice over the rushing water. It created an illusion that Niagara Falls was frozen all over. In reality, the water kept flowing beneath the ice. Imagine ponds filled with ice-cold water and covered with ice. Easy, huh? And now picture dozens of alligator snouts that are poking out of the ponds, still and frozen in ice. That's what you'd seen if you had visited the swamps of North Carolina at the beginning of 2018. Despite this terrifying picture, the animals were very much alive. That was a very special crocodile way to survive abnormally cold weather. Since their nostrils were above water, the animals could breathe. Meanwhile, their bodies were in a hibernation-like state. It allowed the animals to conserve energy and stay warm. In the winter of 2018, the inhabitants of the Sahara Desert, one of the driest and hottest places on the planet, woke up to discover a thick layer of snow covering the sand. In some places, its depth reached a staggering 15 inches. Meteorologists had an explanation for this exciting phenomenon. They said that cold pools of air combined with the precipitation of the most recent storm resulted in snowfall instead of rain. It happened in June 2009. People in some areas in Japan left their homes after a heavy downpour, only to find fish, frogs, and tadpoles everywhere. Fields, roads, lawns, and house roofs were littered with these creatures. One man even found 13 carp on and around his truck. No one knows for sure where this bizarre rain came from, but the most popular theory is that a powerful water spout picked up the animals. Then it carried them through the upper atmosphere and dropped them on the unsuspecting people below. In Australia, it sometimes rains spiders. That's because these creatures can balloon. It's a highly unusual way of traveling. A spider climbs to the very top of a tall tree or shrub, and then it spins several strands of silk, which then help the spider to be carried away by the wind. It's not easy to spot ballooning spiders, but sometimes when the weather is especially damp and unpleasant, mass ballooning occurs. millions of spiders set off on a journey to find another place with better conditions. It may look as if it's snowing outside, but no. Those are spiders drifting down to the ground. The world's longest lightning storms happen in Venezuela and can last for 9 hours per day. The heart of the storm is over Lake Maracaibo, and the clouds tower way higher than your regular thunderstorm clouds. This natural phenomenon, also known as Catatumbo lightning, occurs during 140 to 160 nights a year and can produce up to 28 lightning strikes per minute. You've probably heard how they say that lightning doesn't strike twice in the same place. Well, Catatumbo lightning seems not to know about this rule. At least, it doesn't prevent storm clouds from gathering in the very same place year after year. Volcanic tornadoes are possibly one of the most terrifying natural phenomena. When a volcano erupts, it spews red-hot rock and ash high into the atmosphere. And solid lava pieces and hot gases travel down the volcano's slope. When this flow is moving down, some of the trapped gases begin to rise and spin at the same time. They get squeezed by the surrounding air, which makes them spin faster and faster. That's how a volcanic tornado gets born. Luckily, this phenomenon has a very short lifespan. Even though the island of Newfoundland in Canada can't be called the warmest place on Earth, it's still not that cold. But imagine having to shovel snow in front of your house just several days before your summer vacation. Well, that's exactly what happened on the island in June 2018. A cold storm that came from the coast of Newfoundland covered several regions of the islands with a 2-inch layer of snow. On top of that, the temperature broke all the records as well. During a Newfoundland summer, it's about 66 degrees on average, and 90 degrees on a very hot day. But that infamous June impressed people with only 37 degrees Fahrenheit in the morning. Brrr! Morning glory clouds are extremely rare. They look like massive tubes stretching across the sky. They can snake for more than 600 miles, sitting relatively low. Most researchers agree that these clouds appear when an updraft squeezes through the cloud. This creates the signature rolling appearance. The cool air at the back of the cloud makes it sink downward. The best but not the only place to see the morning glory is Australia's Gulf of Carpentaria. If you decide to travel there to see these clouds, choose a period from late September to early November. On March 19, 2018, the inhabitants of Alabama saw huge chunks of ice falling from the sky. It was the infamous hailstorm of Alabama which caused millions of dollars worth of damage. After the hailstorm, the place looked ruined. Broken shop windows, smashed car windshields, broken billboards, and holes in the roofs. But what made researchers really excited was a hailstone found near the town of Cullman, Alabama. This softball-sized monster was more than 5 inches across, setting a new state record. In 2012, the sky over Dorset, England, turned first ominously dark, then yellow. After that, blue gelatinous balls started to fall to the ground. A local man was walking to his garage when he spotted something unusually bright among whitish hailstones. When researchers examined this jelly rain, they found out that the balls were made of the substance used in diapers or potting soil. It's used to absorb liquid. It's still unclear whether the balls fell from the sky, or maybe the melting ice made a few already existing crystals expand in the blink of an eye. In March 2018, people in northern Nevada could see the rarest and most bizarre cloud ever, a horseshoe cloud. It sure looks bizarre and kinda scary, but meteorologists know that this interestingly shaped vortex happens when a flat cloud travels over a column of warm, rising air. This air creates the shape and adds some spin to the cloud's movements. Such clouds are very fleeting and usually last for only several minutes. Cylindrical snow donuts occur when a wind gust decides to play snowballs. It starts to roll some snow across a snowy area. If it was a real snowball, it would eventually become too heavy for the wind to move. But the center of a snow donut is hollowed out. This happens because its inner layer is too thin and gets blown away when the donut is formed. This makes it lighter than a regular snowball. That's why it also rolls further. Unfortunately, you can't just go and find snow donuts. They're rare because they appear in very precise conditions. If nature had its own movie, it'd be a mix of Avatar and Interstellar. And I'm not even kidding. How else could you explain something as surreal as avalanches that spark blue light or pink lakes? The thing is, these aren't CGI, and I'll show you how Earth manages to pull these off. In October 2024, a guy was lucky enough to be at the right place during the right cold night and got to record a blue avalanche. I mean, it was mainly white, but it quickly flashed a blue light while it was running downhill. Now, scientists aren't totally sure how these blue flashing avalanches happen, but they have some ideas. One part of the mystery comes from a thing called triboluminescence, which is when light is created by rubbing or breaking something. It can happen on many different occasions. One of them is with ice structures. This happens because of friction, like when two things scrape against each other, causing a little bit of sparks to appear. It's a cold light, meaning it doesn't come from heat, just from pressure or movement. Sometimes when ice cracks or breaks under pressure, it can make a tiny electrical charge. When something disturbs ice blocks, making it crack, this ignites a reaction. The trapped ions are charged particles, and when they suddenly get released, they start moving around. This big release of energy is what creates flashes of light. In this case, a blue glow or flash of light. All of this happens absurdly fast, so to actually witness this release of light is super rare. In June of 2024, people in the US witnessed a massive emergence of cicadas that only appear once every 13 or 17 years. Cicadas spend most of their life cycles underground. While they're still nymphs, they can spend multiple years feeding on tree roots. Some species can spend up to 17 years under the earth before they're ready to re-emerge to the surface and officially turn into adults. But 2024, both 13-year and 17-year-old cicadas appeared at the same time. And since 13 and 17 are prime numbers, this event only happens once every 221 years. The forests got absurdly loud. You see, cicadas can sing anywhere as loud as 80 to 120 decibels. They usually sing in groups, which is why it tends to get pretty loud. Someone who actually lived through this event said they could yell at full strength while inside the forest and not hear themselves at all. When cicadas come out of the ground, the male insects produce loud songs by vibrating their abdomens to attract females. With millions of insects from both species singing together, you were in for a real-life natural symphony. Some people mistook these cicadas for locusts and called it an infestation. All the way down in Senegal, Africa, lies a unique lake. Arriving there, you might think you're walking out of a spaceship and into an unknown planet. After all, have you ever seen pink water before? The so-called Lake Retba, or Lac Rose, as known by the locals, has become internationally famous for shining its vivid pink color. And yes, you can swim there if you'd like, but you should know the water is extremely salty. Lake Retba is known to be one of the world's saltiest lakes, with a saline level of about 40%. And in case you're wondering why the water is pink, I assure you this has nothing to do with otherworldly factors. It's actually due to the high levels of salt. The algae, known as Dunaliella salina, is the one responsible for the pink shading. These algae produce red pigments that absorb sunlight, giving the lake its striking pink color. But if you'd like to catch the lake at its brightest color, you should go during the dry season, between the months of November and June. In other months, the rainwater dilutes the pigments and its color becomes less distinct. You can also find a bubblegum pink lake in Western Australia. It was actually crowned as the 10th most otherworldly sight in the world. Lake Hillier is shaped like a footprint and measures over 1,900 feet in length. You can really see how the pink stands out next to that deep blue ocean sitting next to it. Hey, look here. Any ideas what this is? Take your wildest guess. Okay, it looks like a river, right? but that doesn't look like water flowing on it. When locals first saw this happening, they didn't know what it was. So, to make things easier, they just called it Sand River. It sure was a good guess, but it turns out that what these people saw is more or less an optical illusion. It's not sand, but it's not exactly water either. You see, in arid environments, it's pretty rare for hails to happen. And in this case, what we're seeing are thousands and thousands of floating hailstones. Simply put, hail is just frozen rain that pours down in the form of small pebbles of ice. Looks pretty magical though, doesn't it? Now, isn't it crazy that something as beautiful as the Northern Lights emerges from a violent encounter? Yep, the so-called aurora borealis is actually the result of solar storms. Here's how it works. The sun, the giant ball of gas, sometimes throws out bits of plasma into space. When this plasma flies away from the sun, we call it a solar storm. These storms travel through space, passing by planets like Mercury and Venus before reaching Earth. When these intense solar storms hit the Earth's magnetic field, something amazing happens. These particles coming from the sun are captured by Earth's magnetic field. They collide with atoms and molecules in the Earth's atmosphere, and these collisions create auroras, especially near the North and South poles. From where we stand, these flashes look like colorful lights dancing in the sky. But that's not really what's happening. If you zoomed in, you'd see millions of tiny flashes happening super quickly. Oh, and the Northern Lights make sounds too. It's a mix of chirps, crackles, and buzzing noises, like a strange radio signal. And this is the sound of a solar storm crashing into our atmosphere. Does Thor ring any bells? I'm guessing he lives inside this next natural phenomenon. The thing is, sometimes when a volcano erupts, it can be accompanied by huge thunderbolts. Scientists often refer to it as volcanic lightning, and they're still debating as to why this happens. One of their guesses is that when a volcano erupts, it projects charged debris into the atmosphere. These charges then react with other charges already present in the air, which can result in a bolt of lightning. Cool, huh? The first time anyone ever witnessed something like this was during an eruption of Mount Vesuvius in 79 CE. Last but not least, rainbows. Of course, which is the semicircular one we see most times. If you're lucky, you can witness a full circle rainbow, which usually happens in high altitudes, where the line of the horizon doesn't cut the rainbow in half. Ah yes, there's also the possibility of a lunar rainbow, aka the moonbow, which is a very unusual sight. It happens usually during full moons, when the light of the moon is at its brightest, and it's also perceived as a white arc, outlining the moon's outer rim. Let's just wow here for a moment.
Ah, you're on the grass, looking up at the blue sky, enjoying some singing birds and catching some rays. You watch different shaped clouds soaring slowly, high up in the air. Suddenly, you hear a powerful loud rumble coming from far away. You get up and notice a gigantic thick cloud ahead. But it's not the size that scares you, it's the shape. The cloud looks like a skull. Don't worry, it doesn't mean anything bad's gonna happen. Anyway, it's not even a cloud. A few years ago, a skull formed out of thick smoke over Mount Vesuvius in Italy. That's the same volcano that erased the ancient city of Pompeii from the face of the earth. Of course, back then, many people were afraid that the volcano would erupt again. Luckily for everyone, the volcano's still in a deep sleep. It was just a nearby forest fire that caused the famous skull cloud. But the locals weren't so sure. Some thought that the fire and the skull were set on purpose. Wouldn't be the first time. Centralia, Pennsylvania. Population, well, just look around. Looks a little scary. Bare trees, no animals, no people. All the buildings are empty. Roads are all cracked and strewn with gravel. No cars, obviously. Thick smoke everywhere. This town's been burning for more than 50 years. Centralia used to be a mining town. One of its coal mines was abandoned, and locals used it as a dump for their trash. Then, according to most people, the city decided to get rid of the trash in the usual way, by burning it. The plan was a major failure. Let's see what could have possibly gone wrong here. The trash fire got deep into the mine's tunnels, ignited the coal that's still down there, and has been burning steadily ever since. The level of carbon dioxide shot up, and they had to shut down the other mines nearby for safety. No one could stop the fire, and the underground flames spread beneath the city. Roads began to warm up, the soil went sour, and the streets slowly filled with smoke and smog. In 2017, there were only 5 people living there. Welcome to Abraham Lake in Canada. It's completely frozen. You step onto the transparent ice and look down at what lies beneath. No fish, just some mysterious frozen bubbles. They look like small clouds frozen in ice, or jellyfish who forgot to pack a winter jacket. There are thousands of these little bubbles made up of methane. But don't try to dig a hole in the ice to touch it. Methane is highly flammable. It's created by methane-producing bacteria that eats leaves, grass, insects, and any other organic stuff that gets into the lake. When the methane touches the frozen water, it turns into tens of thousands of frozen little balls. When the ice melts, they burst open and sizzle. If you lit a match over them at just the right moment, the lake would look kind of like an erupting volcano. Similar lakes can be found near some shores of the Arctic Ocean. There, the size of the bubbles can reach several times the size of hot air balloons. Beautiful for sure, but not exactly safe. The next shocking lake is in Indonesia, on the island of Java. You come to a majestic volcano overgrown with grass and trees. The volcano seems to be asleep, but smoke is pouring out of it. You, of course, climb to the summit. Exhausted, tired, sweaty, you're ready to cool off. Nice work, you made it to the top. You look into the mouth of the volcano. No boiling lava, just a beautiful, bright turquoise lake down there. It looks like an oasis. Perfect time for a refreshing dip. You run down and get ready to jump in. But that's not water, that's acid. Sulfurous gases get into the lake from under the volcano. The lake itself is full of metals. When the gases touch them, they form that beautiful turquoise water, acid. Better head back to the nearest village, rest, and come back at night when it's cooler. In the dark, the lake seems to grow. Right above it, you see light-filled, exploding little clouds. The sulfurous gases rise out of the lake, combine with the air, and flash bright blue. Still, don't get too close. Up in the sky, underground, volcanoes, lakes? Time to head out to sea. You get on a yacht and sail off. It doesn't matter where, this next one happens all over the world. So, the sea is crystal clear and calm, there's no wind in your sails. Everything is so peaceful. Wait, what's that? You hear a loud noise. 2 seconds later, a huge wave, way taller than your mast, rises from the calm sea and hits your yacht. The ship manages to stay upright and the huge wave disappears. You just survived the attack of a rogue wave. Some scientists think it happens when the surface sea current smashes into a strong headwind. Others say it happens when warm and cold currents come up against each other. Another popular theory is wave interference, where small waves team up to form one monster one. Under certain conditions, waves get a sort of superpower. Out of all the waves in the area, there'll be one which sucks the energy out of all the others. When it's full, the wave spits it all out. Maybe that's why the wave's so strong, but only lasts an instant. What about clouds? Scary? Well, they can be, if they're huge thunderclouds, walls of gray and black blocking out the sun, the moon, and the stars. First, you're relaxing in your backyard, then you see thunderclouds. Then you get thunderstorms, hail, floods, and even tornadoes. They're easy to spot thanks to their epic appearance, thick, heavy, and dark. They can even sparkle inside because of lightning. That's one scary-looking cloud. But before you run away, let's see how it forms. Clouds are like roller coasters. Imagine you're a small drop of water hanging out with your friends in the ocean, waiting in line for the brand new ride that just opened up. It's time. You strap in. nothing happens. Then you feel it. The roller coaster starts to go up, up, up. You can see all your droplet friends down there. They're so small. You keep rising, just waiting for the big whoosh, but nothing happens. Then you're so high up that you're in the clouds. It's not so scary up here, and there are loads of your friends. Nice. It's starting to get cold. You look around, it's happening to everyone. You're being turned into beautiful ice crystals, so shiny and pretty. The clouds filling up, getting kind of cramped with all those other water droplets. Still, what a peaceful, enjoyable, wow! The ride kicks back in and you start to free fall. Slowly at first, then faster and faster, thousands of your fellow drops falling back to Earth, some holding on tight to the handrail, some laughing and waving their hands in the air. Woohoo! And splash! Still, I like the lightning ride better. That's one where they strap you in, you ride up, and then you play bumper cars way up in the clouds. The more times you bump into another water droplet, the more lightning you create. Now, not all lightning happens inside clouds. There's a rare phenomenon called a dirty thunderstorm. The lightning happens above a volcano. The most famous is in Japan. It erupts almost every day and spits black clouds high into the air. So, it's super scary volcano clouds, plus lightning. Whoa! Regular lightning happens during a storm when ice crystals bump into each other. In a dirty thunderstorm, bits of volcanic ash collide, create friction, and spark up the sky. Okay, better finish the journey with something safe and beautiful. No more cloud roller coasters, please. You're in the Atacama Desert in northern Chile, one of the driest places on Earth. But this desert has a beautiful secret. Every 3 to 5 years, flowers pop up out of nowhere. It's so famous, it's also called the flowering desert. Seeds lie around in the ground just waiting for some rain. When the desert gets enough water, about 200 types of flowers sprout up. The yellow sands of the Atacama turn purple, white, green, and pink.
In December 2014, an entire district in Budapest got covered with ice crystals. The trees in the area couldn't handle the pressure from the ice and they started toppling over. It was a spooky occurrence called ice fog. When it happens, the temperature drops significantly, freezing everything around, like Dementors did in the Harry Potter movies. All thanks to a temperature flip-flop. It not only messes with what you can see, but also creates ghostly pillars and halos that glow in the dark. Ice fog is made up of tiny ice crystals. When it's below 14 degrees Fahrenheit, water droplets in the air freeze and turn into ice crystals. Until then, they stay liquid unless they find something to freeze onto. Ice fog usually forms in chilly parts of the world like the Arctic or Antarctic. Budapest was a plot twist. Hot, moist gases from vehicles and planes can also create ice fog. One plane takes off on a cold day and boom! There's so much ice fog that the next plane can't see a thing. That sometimes happens. It's not the same as diamond dust, which is when sparse ice crystals fall from a clear sky. It forms when the humidity is super high, nearly 100%, and the air temperature drops way below 32 degrees Fahrenheit. This creates ice crystals in the air, and they end up settling on different surfaces. Interestingly, early settlers thought these ice crystals could get into their lungs and cause some trouble. There are many other interesting ice formations, such as rabbit ice. It occurs when the air is chilly but the ground is yet to embrace the frosty vibes. The sap inside plant stems expands as it freezes, making the stems crack open. Once it happens, liquid slips out, meets the frosty air, and turns into thin layers of ice, creating beautiful petal or ribbon-like formations. Earthquake lights are another weird and unique phenomenon. When a powerful magnitude 8.1 earthquake hit Mexico in 2017, images of strange green and blue lights in the sky flooded social media. These so-called Mexico earthquake lights added another layer of mystery. Similar to ball lightning, earthquake lights are pretty rare. Fascinating, but tough for scientists to figure out. What makes it tricky is that the instances of luminosity around earthquakes don't all look the same. There are both theories and myths about this thing. The lights can appear in many different shapes, forms, and colors. Digging into history, researchers examined 65 accounts of these lights dating back to 1600 CE. For instance, on November 12, 1988, people reported a bright purple-pink globe of light along the St. Lawrence River in Quebec, just 11 days before a powerful quake. In Pisco, Peru, the lights took the form of bright flashes captured on security cameras before an 8.0 magnitude earthquake in 2007. And before a 2009 earthquake in L'Aquila, Italy, folks saw 4-inch flames of light flickering above a stone street. Yet, there are still debates about whether earthquake lights are real or not. The U.S. Geological Survey is a bit cautious, not sure whether individual reports of unusual lighting around the time and place of an earthquake truly represent earthquake lights. In one study, scientists theorized that these lights were caused by electric charges activated in specific types of rocks during seismic activity, like turning on a battery in Earth's crust. Some rocks, such as basalt and gabbro, have tiny crystal defects. They might release electrical charges into the air. Researchers estimated that the conditions needed for the creation of these lights existed in less than 0.5% of earthquakes worldwide. It could explain their rarity. They also noted that the lights tend to show up more often before or during quakes than afterward. An earlier study suggested that tectonic stress could create a piezoelectric effect where quartz-bearing rocks produce strong electric fields when compressed. Yet, studying earthquake lights is tough because they're unpredictable and short-lived. Time to talk about a sudden ring around the moon or sun. You're walking with a friend and suddenly see this sun halo. It's nature's warning. A snow or rainstorm is coming. These halos form when bazillions of tiny ice crystals in clouds refract sunlight. Resist the temptation to stare at this wonder directly. It can damage your eyes. Grab sunglasses and then admire it for about 40 minutes. Nature sends other early warnings too. If the sea mysteriously recedes, showing coral and fish, a tsunami might be on the way. Watch out for rip currents on the beach. Sharks might be fleeing a storm if they come unusually close. Feeling your hair stand on end and jewelry buzzing? Lightning might strike nearby. Seek shelter. Avalanches, green storms, and lakes near volcanoes are all potential dangers. Cross seas are extremely dangerous. Cave exploration during a full moon might cost you your life. If the ocean turns reddish-brown, avoid swimming. There might be toxic algae in the water. Animals sense disasters too. If they act strangely, pay attention. There's a fascinating blue glow around Matsu Islands on summer nights. It's caused by tiny glowing creatures. Tourists love watching this beautiful spectacle, but there's a downside. It's toxic and getting bigger each year, as revealed by a study. Despite its romantic appearance, this phenomenon is harmful. A team of oceanographers used satellite data to track its growth over 19 years. After analyzing almost 1,000 satellite images, they concluded that it was expanding into deeper waters. Unfortunately, this expansion poses a threat to marine life. The bloom of blue tears can poison fish and sea turtles and even affect human health. While dinoflagellates themselves aren't toxic, their food, toxic algae, releases harmful chemicals into the water. This process depletes oxygen, endangering marine animals. The main cause is unclear, but pollution from agriculture down the Yangtze River seems to play a crucial role. Agricultural runoff introduces nutrients that fuel the bloom. During the construction of the Three Gorges Dam project, the bloom's size reduced when the river's flow decreased. After the dam was finished and the river started flowing strongly again, the bloom resumed its growth. The team predicts that blue tears will keep expanding, posing an ongoing threat to marine life and creating more vividly glowing waters. A katabatic wind or drainage wind happens when dense cold air descends from a higher elevation down a slope due to gravity. These winds can be powerful, sometimes reaching hurricane speeds, but rarely. Unlike all downslope winds, katabatic winds like the Bora in the Adriatic or Santa Ana in California originate from cooling air on elevated surfaces like plateaus or mountains. As the air descends, it warms up. Its temperature depends on the source region. In Antarctica, katabatic winds are crucial in shaping wind fields. In regions such as Greenland and Antarctica, these winds can become extremely intense, reaching hurricane force. They contribute to unique phenomena, such as the McMurdo dry valleys in Antarctica, and are associated with such dangers as willowas in the Fuegian Archipelago and Alaska. St. Elmo's fire is a natural phenomenon worth mentioning. It happens during thunderstorms or volcanic eruptions when there's a strong electric field around the area. It creates a bluish or violet glow around such things as ship masts, airplane edges, or sharp objects. This glow is caused by ionized air molecules and is more noticeable in low light conditions. The glow is a form of plasma, and it happens when the electric field around an object causes the ionization of air molecules. This can occur during thunderstorms because there are high voltage differences between clouds and the ground. Sharp points make it easier for St. Elmo's fire to occur because the electric field is more concentrated in those areas. The colors you see, blue or violet, come from the fluorescence of nitrogen and oxygen in Earth's atmosphere. Similar to how neon lights work, but with different gases. From ancient Greece to 15th century China, this phenomenon has been seen throughout history.
Ah, beautiful. You're walking with your friend and look up at the sky. The sun looks a bit different today, like it has some kind of ring around it, a rainbow type thing. Huh, look at that. Your friend pulls his head up out of his phone. You shouldn't look directly at the... Stop everything, he says. It's a sun halo. We need to find shelter now, unless you have the world's biggest umbrella on you. A sun halo is nature's sign that there's a snow or rainstorm on its way. It's caused by clouds that are made of bazillions of small ice crystals. Sunlight goes through those crystals, which causes the light to split and refract, like when there's a rainbow. Now, don't look at the sun halo directly. It's going to be tempting because it's not something you see every day. Plus, it's really beautiful. But ultraviolet light can burn the exposed tissue of your retina and cause serious damage, so it's not worth it. Grab some sunglasses and you're good to go. This phenomenon lasts around 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. In June 2020, what the people were looking at was an anvil cloud, a rare storm formation in the sky. Formed when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky, with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud that they thought something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area, regardless of how strong the wind is. If you look off the western coast of France, you'll see the Isle of Ré. Thanks to its beautiful blue waters, clean sandy beaches, and stunning lighthouses, this place is a very popular vacation spot. But perhaps the coolest part about the island of Ré is what you see just beyond the shore: square waves. This strange wave pattern looks like a giant chessboard over the ocean. Many visitors to the island become captivated by these waves and go to high-up places like nearby lighthouses to take pictures of this natural phenomenon. They say that when looking down at these square patterns in the water, it's almost as if there's some sort of metal grid underneath it. And while these wave patterns are truly fascinating, the people who choose to enjoy them from afar are doing it right. They know to stay out of the water. To understand how these square waves come to be, it's important to know how waves occur in the first place. Generally, waves can travel many miles over the surface of the water, depending on local winds and weather. And even on days when the weather seems somewhat calm, storms located elsewhere can send in crashing waves that affect the surrounding calm waters. When waves travel onto the shores of distant lands, they're called swells. This is different from a wave that occurs from local wind. When two different swells coming from opposite directions meet, it's known as a cross sea. This is what generates these square waves you see near the Isle of Ré. While these waves are one of the reasons why people flock to this island, they can still expect to enjoy calm, relaxing waters most of the time. The cross sea only occurs during certain times of the year in specific weather. Plus, it's common knowledge around Ré to steer clear of the ocean when these square waves appear. So it's not often that you hear about anyone getting caught in them, because most people know better. And since a lot of people on the island are tourists, there are plenty of signs around warning them to get out of the water during this time. However, not everyone gets the memo. There have been a handful of cases where people got caught in the cross sea, but thankfully and luckily, they managed to get out safely. These square waves have become somewhat famous over time, given that there's really no other place in the world that boasts a cross sea like this one. In fact, no one has ever spotted square waves anywhere but the island of Ré. However, there are swells that can be found throughout the oceans in the world, and a cross sea can take place. But if the angle they approach each other at is more shallow, the wave may actually look like it's coming from the same direction, even when it's not. Not to mention, swells can slowly lose momentum as they drift further and further away, so their crest, or the top of the wave, appears more round and less jagged. The island of Ré's specific wind and weather patterns are literally the perfect storm and create a cross sea that people can clearly recognize. It's 2009 in Italy. A man was hanging out in his kitchen. Then he saw some flickering lights. He knew just what to do. He moved his family to a safe place. A couple of seconds later, a massive earthquake hit the whole region. His family survived thanks to his quick reaction. He knew these flickering lights were actually a sign of an upcoming earthquake. People have been seeing these mysterious lights for ages. Some thought it was some kind of sign coming from space. Scientists never used to take them seriously, but after the invention of photography, more and more evidence of these strange lights appeared. Soon, they realized the connection. The lights appear, and pretty soon, the earthquake hits. After a bit of digging around, they actually found some records of these earthquake lights from hundreds of years ago. There were bluish flames coming out of the ground right before an earthquake. Oh, creepy. The Christmas Island crab is part of an amazing phenomenon once a year. Their migration period is determined by the phase of the moon and the first rainfall between October and February, although the precise date can't be predicted. Once the crabs have been prompted, they leave their homes amongst the forest and migrate in massive hordes towards the sea. Numbering in millions, a sea of red crabs is observed as they make their journey across the island, creating roadblocks and making their way to the ocean. There, they lay their eggs and then make their trek back, returning to the forest until the next year. There are bridges in the Indian state of Meghalaya that are created entirely of living tree roots. The bridges are made up of tangled, thick roots that are strong enough to hold over 50 people at a time. The Khasi and Jaintia tribes became masters in the art of growing these insane bridges. They need them to cross the streams below with ease. Some of these root bridges are over 180 years old. To make them, the members of the tribes care for the roots until they grow long enough to reach the opposite bank. It can take as long as 10 to 15 years to grow a bridge. In the process, the roots become tightly entwined with one another. This is how the bridges get so strong. and once a bridge is fully grown, it can last for over 500 years. While some roots decay, new ones are continually growing. That's why the unusual natural constructions last so long. Light pillars are colorful beams of light that either jet up from Earth towards the sky or shine down from the clouds. Usually, they only occur in cold temperatures, as they form when the sunlight gets reflected off ice crystals floating in the air. The higher the crystals are in the air, the taller these bright and colorful pillars become. They're most common at sunrise and sunset. There are hidden caves all over the world that are filled with glowing light. This light comes from hundreds of glowworms that have made a cozy home in the caves. Some of the caves are more than 30 million years old, and most of them can be found in New Zealand and Australia. The worms themselves don't actually glow, but baby worms, called larvae, form silk strings made out of mucus. These strings form nets. It's these nets that can illuminate the entire cave. Their purpose is to attract flies and other tasty insects for the glowworms to munch on. Rainbow trees are 100% a real thing. Hailing from the Philippines and Indonesia, these colorful wonders are called rainbow eucalyptus, or rainbow gum. The rainbow hues are created by the contrast in colors of old and new bark. As the thin surface layers of bark peel away, they reveal newer ones with brighter, more eye-catching colors. The brand new bark is green. Then it changes to purple, then red, and finally brown. This is because the trees contain a substance called chlorophyll. It makes the bark green. As each strip of bark ages, it loses chlorophyll and slowly changes its color. Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the U.S. was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle, near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the Draco chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a Draco to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So a Draco is kind of like a small, average level 1 to 2 tornado. Usually its speed is within the range of 73 to 113 miles per hour. And in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a Draco if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to Dracos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, scientists don't have an exact explanation. But although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen.
In January 2022, a volcano eruption happened in the Tonga Islands that forever changed the way we understand GPS signals. This volcano caused a massive disturbance, sending out a colossal mix of gas and debris in the air. It generated a shockwave that traveled across the entire atmosphere, reaching all the way to Alaska, and launched a tsunami over nearby islands. Over northern Australia, it crafted a weird plasma bubble in the upper atmosphere, which disrupted GPS systems for hours. People that happened to be under this bubble and in need of precise GPS waited for ages before their device could receive precious information again. The exact place where these disturbances occurred is called the ionosphere. It's the place where our atmosphere meets outer space and looks like this buzzing layer where heat from the sun turns gases into electrically charged particles. It can also be seriously unpredictable, changing depending on the weather and thinning out when the sun's rays are less powerful. Because it's electrically charged, the ionosphere helps us with our communication needs. It houses many satellites, including the International Space Station. Here's how changes in the ionosphere can interact with GPS signals. Let's say you're playing detective with your friends and need to find them using a special radar. This radar sends out invisible waves through the ionosphere to locate your buddies. If everything is normal, you'll find their precise location in no time. Should those waves go through a place where the ionosphere particles are a bit messed up, the waves might slow down, get scattered, or change direction, confusing your radar. In the same way, when GPS signals travel through a damaged ionosphere, they can malfunction. Scientists have developed a way to fix this, like special sensors to anticipate changes in the atmosphere. The ionosphere is also sensitive to rockets being launched from Earth, not just storms and volcanoes. At first, astronomers believed these red patches they were noticing in the sky were similar to the northern lights found in Sweden, Finland, or Canada. But they soon figured out there were gaps in the ionosphere. Beautiful to look at, yes, but experts are worried that these crimson areas might be causing communication and astronomy problems that we've yet to discover. Since scientists don't know all the effects of these holes on our environment, it's best to steer clear if you see a red hole in the sky, just to be safe. But at least they seal up within 10 to 20 minutes. Mars has its own eerie set of lights happening in the atmosphere, and you'd think, since it's the red planet, these lights would also be red. Should you ever land on its surface, surprise! At times, the sky turns to a green glow. This unexpected hue could be very important for future Mars trips, since it can help specialists better understand the Martian atmosphere. Or what's left of it. That's because at some point in its history, Mars switched from being a warm and wet world to the cold, dry plains we know today. How is Mars slowly losing even what's left of its atmosphere? One popular theory is that Mars's weak gravity, combined with the fact that it doesn't have a strong magnetic field, lets the atmosphere escape into space. This vulnerability comes from the solar wind, a constant flow of particles from the sun. The sun's push over millions of years may have thinned out the atmosphere, grabbing the lighter parts. Some scientists suggest another possibility. A colossal impact by another object might have swiped Mars's atmosphere away. Studying this greenish glow is key to understanding what's going on the Martian atmosphere, a place satellites can't directly explore. Since we plan to visit this neighboring planet in the following decades, scientists intend to develop the perfect spacecraft. Knowing its atmospheric density helps us build machines tough enough to handle Martian drag, and we can design parachutes that gracefully descend to the Martian surface. See these amazing purples and greens lighting up the sky? That's not your typical aurora. It's Steve. First discovered by regular people, not scientists, some years back. We now know it's the aurora's more elusive cousin. Steve is short for Strong Thermal Emission Velocity Enhancement and was caught on camera back in 2018 by a bunch of amateur aurora chasers in Canada. They then brought it to the attention of NASA scientists. Here's how this is different from the aurora, starting with the appearance. Steve is more of a magenta streak, while the aurora is usually made out of green ribbons. Auroras happen when particles from the sun interact with the Earth's magnetic field and atmosphere, causing gases to emit light. Steve is thought to be a separate optical phenomenon that sometimes appears alongside auroras. While the exact mechanism behind it is still being studied, scientists believe it is linked with charged particles in the ionosphere that also interact with the Earth's magnetic field. Now that we know where to look, Steve might not be as rare. If you're planning to catch a glimpse of it, you'll need to travel to places where auroras usually happen, like Canada, Alaska, Northern Europe, New Zealand, and Australia. That's because it's never visible on its own. It's powered up when the aurora is extra bright during geomagnetic storms. Auroras can also happen on the sun too. These luxurious lights happen somewhere around 25,000 miles above a sunspot, a dark magnetic patch on the sun's surface. Astronomers have only recently discovered our own sun is capable of generating these lights. So far, they've only spotted aurora-like signals from faraway stars. Here on Earth, the aurora can last anywhere from 15 to 30 minutes, maybe even a couple of hours if you're lucky. On the surface of the sun, though, this phenomenon is a week-long display of intricate lights. Strange lights in the sky can also happen before an earthquake hits. Mexico had its share in 2017, lighting up the internet with pictures of weird celestial shades before a massive magnitude 8.1 earthquake. Some voices in the scientific community wonder if this light phenomenon is indeed connected to earthquakes at all. Others have this theory that such lights are caused by the release of ionized oxygen from the breaking of certain rocks. A photographer from Finland captured these shots of a circular rainbow display in the sky and wondered what might be causing it. It's something pretty ordinary: pollen. These colorful rings are called pollen coronas, and they happen when sunlight hits the pollen in the air at a certain angle. You can easily tell if you're looking at pollen coronas if they're accompanied by star-like sparkles. Those are individual pollen grains, and they come in many sizes. The process is very simple. Sunlight hits the pollen and scatters into different colors. Some colors get blocked or crash into each other, creating a pattern known as diffraction. The pollen in these images is from pine trees, and under a microscope, they look like tiny Mickey Mouses. Those ears are actually air pockets that help them float in the wind. The air sacs all line up in the same direction, creating the elliptical shape of the rings. For these coronas to show up, pollen levels need to be very high. An astronaut up on the International Space Station once snapped this picture of our planet, showing these two weird blue patches of light in our atmosphere. They might seem related to each other, but these lights are two different natural phenomena that just happen to be captured at the same time. The first one, down at the bottom, is a massive lightning strike that zapped somewhere in the Gulf of Thailand. Lightning is usually pretty hard to spot from way up there because of clouds, but this time it struck between them, firing up the walls around it like a luminous ring. The second blue blob up in the top right happened because of the moon. The way our natural satellite lines up with the space station lets the sunlight it reflects shoot straight through Earth's atmosphere. This turns it into a bright light with a fuzzy halo. It happens because some of the moonlight bounces off tiny particles in our atmosphere, making the moon look blue in this picture. That orange halo curving along Earth's edge is just the atmosphere.
Hi there. Have you ever wondered why birds tend to fly in circles? It's because of thermals. Now, a thermal is like a big bubble of warm air that rises up from the ground. Have you ever flown a kite on a windy day and watched it go up and down? Well, imagine if the wind was warm instead of cold, and instead of a kite, you were a bird or a glider. So yeah, that warm wind would be a thermal. Thermals occur when the sun heats up the earth, and the air close to the ground gets warm and starts to rise. This creates a column of rising air that birds and gliders can ride on to go up into the sky. Just like how you use the wind to fly a kite, birds can use thermals to soar without flapping their wings too much. They can circle inside the thermal and go higher and higher without using up too much energy. Those that especially tend to use this flying in circles mode are large raptors, such as hawks, vultures, and eagles. When these birds circle in the sky, it looks like they're just hanging there. But nope, it's all about thermals again. It helps them because as they go higher without getting tired, they can look for food more easily or watch out for predators from a good position in the sky. Thermals are important for some other animals that fly too, like insects. You may see lots of birds flying in circles together. Sticking together helps them save even more energy. Some birds, like geese and ducks, tend to fly in a V formation to save their strength. What's interesting is that all the birds in the flock take turns leading the V. As they fly, the birds at the front get tired, so they fall back, and another bird takes their place as the leader. This way, every bird gets a chance to rest and save energy. Thermals can also create powerful storms, like thunderstorms. And sometimes, when you see birds flying in circles or a V shape, it's because they sense a storm is coming. This happens because bad weather comes hand in hand with low pressure. Low pressure systems are areas in the atmosphere where the air pressure is lower than the surrounding areas. When the pressure drops, it can cause the air to move and create wind. If there's enough moisture in the air, the low pressure can even cause thunderstorms, heavy rains, or even hurricanes. Migratory birds are often those who use their keen sense of hearing and vision to detect changes in weather conditions. When a storm is approaching, there can be changes in air pressure, wind speed, and temperature, which can affect their behavior. Some other animals have interesting types of behavior when the bad weather is coming too. Cows and other livestock may huddle together in a group for warmth and protection during a storm. Also, cows are known to lie down in a field before a storm as a way to ease this discomfort, or at least that may be something you've heard. So, what have you heard about this herd? Well, the belief is that cows predict the weather and lie down because they can feel a drop in air pressure that comes with an approaching storm. But science hasn't confirmed it yet, since there's not enough evidence to support this idea. Cows do like to lie down from time to time, but they do it for a variety of reasons, such as to rest or ruminate. So when you see one lying down, you can't be sure it's because bad weather is coming. Different studies showed different results. One found out cows didn't show any significant changes in behavior before the rain, while another study found that cows stood up more often as the rain was coming. Apparently, no one has actually asked the cows about this, but the cows aren't talking, which is why this point is moot. Amphibians, such as frogs and toads, can give us information about natural phenomena. When you hear frogs croaking louder and longer than usual, it might indicate that a storm is approaching. Frogs are sensitive to changes in humidity and air pressure, and they tend to become more active and vocal just before a storm. And when it comes to toads, research says they might even predict earthquakes. This is because before an earthquake, there are changes in the chemistry of the ponds where toads live. The shifts in the ground causes these changes, which in turn causes the toads to flee their homes. Scientists believe we should study these patterns to predict earthquakes more accurately. Meanwhile, dogs can sense storms and thunder too. They feel changes in the air pressure in the atmosphere. Plus, they have a way better sense of hearing and smell than humans. When a storm is approaching, you can spot certain things in their behavior. For instance, they may become more restless or clingy. They may pant excessively or pace back and forth, and they may try to hide in a safe place. This is because dogs can feel the static electricity that builds up in the air before a storm, and they may become anxious or frightened by the loud noises and bright flashes of lightning. There were stories that dogs can predict earthquakes too, but there's no firm evidence of that. But who cares? Dogs are our heroes even without that. Now, honeybees can sense changes in pressure and humidity levels as well, so they use this information to predict when a storm is coming. These are social insects that live in large groups in hives or colonies. That's why predicting weather is so important for them. They need to protect their hives and forage for food before the storm hits. So for bees, bad weather may come like a real vacation they've wanted for so long. Just some chillin' and eating all the food they've gathered before. Just like me in a sense. Spiders have superpowers when it comes to weather too. Well, they can't exactly predict the weather, but their behavior can give us a clue about temperature outside. When it's going to get colder, spiders might seek shelter indoors. So, if you see many spiders in your home, it could be a sign that colder weather is on the way. You may have heard snakes can predict earthquakes. The legend where this belief started actually dates back to 373 BCE, when snakes and other creatures are said to have left the area before a major earthquake in Greece. Cool story, but there's little firm evidence to support the theory. Scientists do acknowledge that snakes and other animals can sense earthquakes a few seconds before people do, because they can feel the initial wave better. But it's still not clear if they can detect it days in advance. How about sheep and their sixth sense? It allows them to predict rain or snow. They huddle together tightly before a storm, which could be a way to keep warm or protect themselves from the weather. But this theory needs to be yet appropriately tested and proven. You will hear wolves howling during big storms as well. Many people think wolves do it when a full moon is outside. But some experts believe the change in air pressure that comes with a big storm may cause discomfort in sensitive canine ears, and this is what makes them howl. But again, it's hard to tell precisely because wolves howl for many reasons. They do it to signal danger, attract a mate, and communicate with their pack. There's also no evidence the full moon fascinates them so much that they feel the urge to howl when they see it. But it's good for the movies, though. Sharks have ears sensitive to changes in air and water pressure that usually occur during hurricanes and tropical storms. Some experts believe they can detect these and quickly dive into deeper waters to stay safe. Studies showed sharks behave like this many times before storms. Again, no one's sure 100% about this, but like many other animals, they do have a special ability to detect changes in their environment and use it to survive and thrive over time. A purple sunset. You must have seen one of those at least once in your life. Normally, it's nothing ominous and has to do with the way light travels. The light that the sun produces is white. When it goes through a prism, you see light waves of different colors, from red and orange to blue, green, and indigo. Light normally travels in a straight line if there's no obstacle in its way. The shorter light waves, including blues and purples, are scattered easier when they meet with those obstacles, like molecules and aerosols in the atmosphere. Because the sun is low on the horizon at sunset and sunrise, its light has to pass through more molecules that scatter the violet and blue light. The colors that your eyes pick up, then, are yellow, orange, and red. But with the right conditions, you can see the gorgeous purple sky. Sometimes purple sky appears for much scarier reasons. It can be caused by hurricanes, wildfires, or dust storms. The concentration of vapor in the air increases, and the light scatters more than usual. Dust, a setting sun, and low cloud cover all contribute to this natural show, too. The sky turns orange and red at dusk if there's still enough light. Then it gives off pink hues, which mix up with a dark blue sky above. Now, do you remember what happens when you mix pink and blue? You get the color purple. Not every hurricane makes the sky turn purple, and trying to predict if it's going to happen is like trying to forecast a rainbow. Still, people reported several major hurricanes made the skies turn purple. Now, green skies might look just as spectacular as purple ones, but they actually also scream danger. They're usually there to tell you a thunderstorm, hailstorm, or a tornado is somewhere nearby. The unique color is a result of yellow sun rays getting mixed with the blue light coming from storm clouds. So you're enjoying a nice day by the ocean with a fresh breeze in your hair, when suddenly you notice the water starts retreating from the beach at a huge speed. This is a sign for you to start running as fast and far away from the beach as you can. This most likely means that a tsunami is on the way. A quick reaction maximizes your chances of survival. Now, if you notice the sea level is rising, but it doesn't seem too extreme, it could be another sign of an approaching tsunami. It happens in 40% of cases, and the incoming water is the first tsunami wave. The next one, way larger and more dangerous, usually follows in about 10 minutes. Another thing about tsunamis is that they like to arrive with some loud sounds. People describe them as thunder, the sound of a locomotive, a helicopter, or just a loud boom. Do you see a channel of choppy water on the beach? It's in your best interest to stay away from the water. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange break in the waves, or an area with a different color than the rest of the water. Random bits of seaweed going in all directions is another rip current warning sign. If you happen to find yourself caught in a rip current, try to stay afloat, but don't try to go against the current. You'll only waste precious energy. Scream for help and try to float your way along the beach. Once you break out of the current, swim diagonally to the shore. The next time you spot conically shaped clouds in the sky, remember it's a good time to start looking for some shelter. If it just stays like that, a severe storm is on the way. But if a cloud of that shape starts spinning around, it means it's about to transform into a tornado. If you have bees nearby, they can save you from big trouble one day. These hard-working little guys get more active than usual when they feel like a storm is on the way. They speed up to collect more nectar before it hits them, and once they're done with it, they'll always come back to the hive 10 to 15 minutes before heavy rain, even when there are no obvious signs of it coming. Their secret is super sensitive hairs on the back that can pick up electrostatic buildups from storm clouds. For centuries, people have noticed that animals act weirdly a couple of days before big seismic events. Dogs can't stop barking, cows halt their milk, and toads, rats, and snakes leave their homes. It looks like animals can feel smaller initial shock waves that humans don't even notice. Scientists have tried to find some legit explanation for it and run endless tests and experiments. But so far, they're still on their way to explaining this mystery. Can you smell ozone in the air? When a thunderstorm is on the way, it's the most distinct and pungent smell you can pick up. An electrical charge of lightning sets it free from higher altitudes. The other, more pleasant smell of rain is petrichor. Rainwater wakes up molecules on plants, trees, concrete, and asphalt. Their aroma spreads all over the place. You can even feel that smell in your own mouth. All those positive ions in the air that a lightning bolt sets free gets mixed with ozone and your saliva, and that's how you get that bitter metallic taste. When lightning is about to strike, you might hear bizarre crackling, buzzing, or vibrating sounds coming from metal objects nearby. Your palms may begin to sweat, and then you can feel your hair stand on end. That's a clear call for action, and that action is to run for your life. Positive charges are going through your body trying to reach toward the negatively charged part of the storm. Trust me, you don't want these charges to meet. If you see no shelter that you can reach fast, try to make yourself smaller than the objects around you. Drop down your umbrella and stay away from wire fences, metal pipes, rails, and other metallic objects. And don't lie flat on the ground, it's likely wet, which means it's a great conductor of electricity. If you suddenly notice crevices in the asphalt next to your house, it could be a sinkhole warning sign. Inspect your house on the inside. Does that door begin to jam? Or maybe there's a gap where the walls meet the ceiling. Uneven kitchen cabinets and drawers, slanted floors, stairs that begin to slope, water leaking after every rain, and displaced moldings are all signs that a sinkhole is about to open. To find out if it's definitely a sinkhole and how dangerous it is, you gotta consult with an engineering company. If you find a sinkhole that's already there, you gotta stay away from the sinkhole area. Fence or rope it off to make it less dangerous for others. You'll need professional help to fix it. Some volcanoes scream when they're about to erupt. Small earthquakes, which often happen before, produce a hum. It's mostly non-audible to human ears, but sometimes it reaches a frequency that lets you hear it as a strange rumbling or hissing sound coming from the ground. This noise is known as a harmonic tremor. With some volcanoes, it's the sound of magma bubbles vibrating when they're going through crevices in the crust of the earth. But it's not always like this. If scientists manage to understand what exactly causes these volcanic screams, they could create a limited early warning system for volcanic eruptions. If you're out in the wild, pay attention to the water in creeks, streams, and rivers. If its level is quickly falling, even if it's raining, this might be a sign of a nearing landslide. And if you hear a faint rumbling noise or unusual sounds, like boulders knocking together, it could mean debris is on its way to you. It's a sign to head to safety immediately, like right now.